Welcome friends. In this tutorial, we will learn about threaded binary trees and AVL trees. Now let us first see threaded binary tree. Introduction. The null entries in a binary tree can be replaced to store a pointer to the in-order predecessor or the in-order successor of the node. These special pointers are called threads, and binary trees containing threads are called threaded trees. A threaded binary tree may correspond to one-way threading or a two-way threading. This diagram shows one-way threading, and this is two-way threading. Threaded tree traversal. We start at the leftmost node in the tree, print it and follow its right thread. If we follow a thread to the right, we output the node and continue to its right. If we follow a link to the right, we go to the leftmost node, print it and continue. Now let us see a threaded tree traversal. Consider this tree. Here, first we will start from 1, that is, start at leftmost node and print it. Follow thread to right and print the node, so 3 will be printed. The next one will be 5. Follow thread to the right and print the node, so 6 will be printed. Follow the link to the right, go to leftmost node and print it, so 7 will be printed next. Follow thread to right and print node, so now 8 will be printed. Follow link to right, go to leftmost node and print. Now 11 will be printed. Now 13 will be printed. Now let us talk about AVL trees. Introduction. AVL trees were the first invented self-balancing binary search trees. They were named after its two inventors, G.M. Adelson-Welsky and E.M. Landis. They published it in their 1962 paper, An Algorithm for the Organization of Information. Now let us see the definition. An AVL tree is a binary search tree in which the heights of the left and right subtrees of the root differ by at most 1, and in which the left and right subtrees are again AVL trees. With each node of an AVL tree is associated a balance factor, that is left higher, equal or right higher according respectively as the left subtree has height greater than, equal to or less than that of the right subtree. Thank you. In the next tutorial, we will talk about the insertion and deletion algorithms on AVL trees.